The German Jagdpanzer IV tank destroyer earned a nickname among its crews, Guderian's Duck. That name wasn't about its performance, but rather its weight distribution. Because the front end was so overloaded, the vehicle had a tendency to dip its nose toward the ground while moving. This machine became one of Germany's most controversial tank destroyers of the era. While it packed a powerful gun, capable of effectively taking out Allied armor, the vehicle suffered from significant design flaws. German crews were known to be wary of it, fearing technical breakdowns in the heat of battle. The story behind this vehicle begins with strategic disagreements among the High Command, which ultimately led to the mass production of a machine that drew criticism from the troops. By the end of 1943, the German command was facing a complicated military and political landscape. The situation on the Eastern Front had deteriorated significantly after the Battle of Kursk, just as Allied troops were landing in Italy. Industry was being pushed to the limit, trying to compensate for the heavy loss of equipment. During this period, a heated debate broke out within the Imperial Ministry of Armaments regarding the future strategy for armored vehicle production. The conflict arose between Heinz Guderian, the Inspector General of Armored Troops, who had significantly shaped tank doctrine, and ministry officials pushing for new, specialized anti-tank weapons. Guderian disagreed with the concept of developing a new tank destroyer. His position was based on the fact that the existing Sturmgeschütz III and Sturmgeschütz IV assault guns were handling their tasks satisfactorily. His main argument was that it made no sense to spread production resources too thin. Launching a new vehicle required chassis and components, which would inevitably reduce the production volume of full-fledged Panzer IV tanks, machines the troops desperately needed at that time. Heinz Guderian advocated for maintaining the output of standard tanks, fully aware of the difficulty of fighting a war of attrition while facing a resource deficit. Allied manufacturing capabilities allowed them to turn out thousands of vehicles, while German industry provided significantly lower volumes. However, the demand to create a specialized tank destroyer prevailed. The operational situation on the front lines, driven by the advance of Soviet corps and the Allied landings in Europe, dictated the need for means to hold back the enemy's massive numbers of armor. Older model assault guns were no longer always effective against modernized machines. What was needed was a vehicle with a powerful long-barreled gun, a low profile, and sufficient armor suitable for ambush tactics. The chassis of the Panzer IV was chosen as the base. It was Germany's most widely produced medium tank, and its manufacturing lines were already running smoothly. The engineering approach was to take this proven platform, strip off the turret, and replace it with a low-profile armored superstructure. By ditching the rotating turret, the design allowed for thicker frontal armor and heavier weaponry. This turretless layout had already proven its worth with the assault guns. A lower silhouette made the vehicle harder to spot, while the simpler design helped speed up mass production. Its main weapon was to be a 75mm gun, 48 calibers long, powerful enough to take out most targets at the time. Specialists reviewed the plans and saw a lot of promise. The new vehicle featured a low-profile, well-sloped armor and a powerful gun, making it looked at as a highly effective anti-tank weapon. The Vormark AG plant in Plauen was tasked with mass production, and they began gearing up their assembly lines. During the design phase, however, they ran into technical issues. increasing the frontal armor from roughly 2.4 to 3.1 inches, combined with mounting the heavy gun, shifted the center of gravity significantly forward. Despite the extra load on the front road wheels, the designers decided the chassis was tough enough to handle it. That decision would later cause a number of operational headaches for the crews. In January 1944, Formag rolled out the first batch of 30 serial Jagdpanzer IVs. In the history of technological development, this model is often cited as an example of how production compromises can negatively impact a design's potential. The factory worked around the clock to meet the high demand for tank destroyers and assault guns. Finished vehicles were shipped to active units immediately after assembly to replenish their equipment. The production chain relied on a large number of suppliers. Armor plates were made by a firm in Ostrava. The guns came from Rheinmetall Borsig in Unterlys and sites in Kreuznach, and the transmissions were produced at the Zahnradfabrik AG plant in Friedrichshafen. This extensive network was intended to ensure a steady flow of production. By spring, the situation in Germany's industrial sector had become complicated. Allied aircraft began systematic strikes on manufacturing facilities, causing significant damage to the factories in Friedrichshafen. Because of the air raids, gearbox production was disrupted, leaving finished vehicle hulls sitting idle while they waited for transmissions. Production volumes fell far behind schedule. Instead of hundreds of units, the Formag plant was turning out just a few dozen vehicles a month. In April, the production strategy changed. Management decided to stop building Panzer IV tanks and shift all capacity to producing tank destroyers. This measure was dictated by the inability to meet the required output for both types of machines with the existing division of resources. Inspector General of Armored Troops Guderian disagreed with this decision, as expanding Jagdpanzer IV production came at the expense of standard tanks. However, the inspectorate's objections didn't sway the final course. Production hit its peak in June and July, when the Formag factory turned out 120 and 125 vehicles respectively. The manufacturing process was intense. Technical flaws were fixed right on the assembly line, and military acceptance teams rushed system checks to get the hardware out to the troops. During this period, the first reports from the crews began to arrive. They noted the effectiveness of the 75mm 48 caliber gun, which could take out Shermans and T-34s at ranges beyond effective return fire. The vehicle's low profile made it highly successful in ambush tactics. At the same time, however, operational use revealed a flaw regarding the vehicle's armor. The decision to place the armor order with the steelworks in Ostrava was dictated by objective circumstances. The facility had the necessary production capacity, experience, and a favorable geographic location. The relevant department already knew that the locally produced steel was inferior to German equivalents, a fact established even before the war. Nevertheless, there were virtually no other options, given that German industry was stretched to the limit. The drive to avoid delays in getting equipment to the front forced officials to make a technical compromise, hoping that the difference in material quality wouldn't be critical. Experience proved these predictions wrong. Combat conditions revealed the material was too brittle. Hits from 85mm shells and larger caused cracks and internal spalling, even without full penetration. Personnel experienced with Krupp armor reacted negatively to the vehicle's new characteristics. Complaints started coming in from the crews about the reduced level of protection. The 3.1-inch frontal armor, which had high ratings in the design documents, failed to provide the expected safety in the field. It was noted that against small calibers, like 20mm anti-tank rifles, this steel actually showed better resistance than its German counterparts. But in the combat conditions of 1944, that wasn't a deciding factor. Criticism of the protective qualities appeared regularly in reports and the soldiers' personal correspondence. A significant discrepancy emerged between the theoretical resistance charts prepared by the Armament Directorate and the actual results recorded when the self-propelled guns took fire on the battlefield. There were instances where the armor cracked or shattered when struck by shells. The combination of powerful weaponry with protection that wasn't up to the task created risks for the crew during anti-tank missions. On April 20, 1944, a decision was made that shaped the future development of this self-propelled gun. That day, the German leadership was shown a 75mm cannon, 70 calibers in length, a weapon similar to the one used on the Panther tank, which had already proven its worth. The new model's ballistics and armor-piercing capabilities received high praise. An order was issued to focus production efforts on self-propelled guns equipped with this weapon, and to ramp up monthly output to 1,000 units. Although experts doubted whether these production targets were realistic, no official objections were raised. The gun was designated the 7.5 cm Sturmkanone 42, length 70. To fit it inside the vehicle's casemate, designers had to modify the tank version of the cannon. Production orders were placed with the Gustloff factory in Weimar and the Skoda works in Pilsen. Integrating the new weaponry came with technical challenges. The gun was larger and heavier, placing extra strain on the front chassis, which was already near its breaking point. Nevertheless, work began on mounting the gun into the hull. Initially, the cannons were fitted with a muzzle brake to reduce recoil. However, combat experience in August 1944 revealed a significant flaw. Firing the weapon kicked up a cloud of dust, giving away the position. For a vehicle that relied on ambush tactics, this was critical, as it allowed the enemy to quickly spot the machine and return fire. Subsequently, shipments of guns without muzzle brakes began, which improved concealment but increased the recoil. The transition to the new weaponry happened in stages. The Vormag factory couldn't instantly stop producing the previous versions, so production of the short-barreled vehicles was scaled back gradually to make way for the new model. Assembling two types of vehicles at the same time complicated logistics and parts supply. Mass production of the older versions ended in October, with the final units rolling out in November. Over 10 months, 769 vehicles were built, a figure that differed significantly from the planned targets. Production capacity simply didn't allow for the original plan to be realized. Field use of the upgraded Panzer IV 75 revealed a number of design flaws. The combat weight rose to 26 metric tons, which was the absolute limit for the Panzer IV chassis. The long barrel and the frontal armor increased to over 3 inches, caused a significant shift in the center of gravity toward the front. The front road wheels were overloaded, requiring the rubber-rimmed wheels to be replaced with all steel ones, since the rubber tires fell apart so quickly. This imbalance affected performance, causing a permanent nose-heavy tilt. This reduced cross-country mobility, where the long gun barrel could snag on uneven terrain or dig into the ground when crossing obstacles. When driving on slopes, there was a real risk of the barrel plowing into the earth. Mobility was rated poor. Where the standard chassis passed easily, the tank destroyer often got stuck. Drivers faced significant difficulties handling the nose-heavy vehicle. The troops gave it the unofficial nickname Guderian's duck. It described the vehicle's tendency to rock while moving, and also referred to the Inspector General, who had warned about the project's technical risks and waste of resources. The predictions came true. The powerful weaponry was negated by design flaws. For transport, the barrel had to be secured with an external travel lock to prevent it from striking obstacles. This required extra steps, which increased the time needed to switch the vehicle from travel mode to combat readiness. Technical difficulties with the previous prototype forced command to look for alternatives. The Alkett firm, which had developed the original tank destroyer concept, was brought in to do the work. The designers faced a tough task, outfitting the vehicle with a long-barreled 70 caliber gun while eliminating the risk of critically overloading the front suspension. Since there was no time for a lengthy redesign and the front needed equipment urgently, Alkett's engineers had to make a forced technical compromise. The solution was to use a standard Panzer IV chassis and mount an armored casemate directly onto the upper hull. The lack of deep integration and layout changes led to a significant increase in the vehicle's height, causing it to lose the advantage of a low profile. Even though the high silhouette made the vehicle more visible on the battlefield, this approach allowed production to start immediately without stopping the assembly lines. Assembly was entrusted to the Nibelungenwerke plant, which was mass-producing base Panzer IV tanks. The production process was standardized as much as possible. The factory continued manufacturing standard chassis, but instead of rotating turrets, they mounted fixed casemates. The self-propelled gun was designated the Panzer IV 70A, where the letter A stood for the developer, Alkett. From August 1944 to March 1945, the factory produced 277 units. Military inspectors noted the flaws of the tall design, but approved the vehicle due to the lack of alternatives and the need to supply the troops with anti-tank weapons. At the same time, the Formag factory continued producing its own version of the vehicle, with similar weaponry but different design features. The gun was offset to the right of the vehicle's centerline, which helped optimize the interior space of the casemate. The artillery system was protected by a cast mantlet with a distinctive shape, known among the troops as the pig's snout. The horizontal traverse was limited to 10 degrees on each side due to the casemate design. This version was designated V after the manufacturer's initial. So by the fall of 1944, German units were receiving two structurally different tank destroyers with similar names: the tall version from Alkett and the low-profile, nose-heavy machine from Formag. Having different versions made vehicle identification difficult and complicated logistics, since the spare parts were different and they required different tactical approaches. The tall silhouette of one version made camouflage and ambushes difficult, giving away its position from a long distance. However, its off-road performance proved superior. The balanced weight distribution allowed it to move over rough terrain without burying its nose in the ground. Combat experience highlighted the technical characteristics of both models. The 70 caliber gun proved highly effective, capable of penetrating the frontal armor of Sherman and T-34 tanks at ranges of nearly a mile. The ammunition load of 55 rounds was smaller than in previous models, but the gun's superior ballistics compensated for this reduction. The main challenge was finding a good firing position. On the Eastern Front, during the winter of 1944–45, amidst the German retreat, these vehicles were used in an attempt to hold back the Soviet offensive. The Jagdpanzer IV served as a mobile anti-tank reserve. These units were rushed to critical sectors to ambush tank groups that had broken through the lines. A single vehicle, sitting in a good, camouflaged spot, could halt an entire column. However, the harsh conditions of the retreat and constant off-road marches took a heavy toll on them. Under these circumstances, their mobility and reliability were rated poorly. The vehicles would get stuck, and the overloaded front road wheels often broke or fell off entirely. On the Western Front, the situation was unique. American and British forces advanced methodically, backed by massive artillery and air support. Attempts to hold back the Allied advance were complicated by the quality of the Czech-made armor. Hits from large-caliber rounds caused structural damage that shouldn't have happened given the armor's thickness. Crews were forced to rely less on their armor and more on stealth and getting the first shot off. If they were spotted too soon, the chances of losing the vehicle skyrocketed. The taller variants built by Alkett were even more vulnerable because of their high profile, making them easy targets to spot. By the fall of 1944, mass production of this model began to wind down. In October, the last major batch of vehicles was manufactured, and by November, only 2 final units rolled off the Vormark assembly lines before production came to a complete halt. Over 10 months, the industry turned out 769 tank destroyers, a stark contrast to the original plan, which called for assembling 1,000 units every month. Allied air raids, raw material shortages, and disrupted component supplies meant that the actual volume of equipment reaching the front fell far short of projections. Every single vehicle produced was sent immediately into active combat zones. During the winter of 1944–45, amidst massive clashes across Europe, German forces were engaged in heavy defensive operations. The tank destroyers were used to stabilize the front line, rapidly redeployed between sectors, and pushed to their absolute limits. Armored vehicles originally designed to fight tanks from ambush were often used during combat to respond rapidly to crisis situations. These machines were rushed to breach points on the front line to temporarily hold back the enemy's advance. The Ardennes offensive in December 1944 marked the last major German push in the West. In an attempt to change the strategic situation, self-propelled guns were attached to tank divisions to bolster anti-tank defenses. The initial phase of the offensive saw some success. The element of surprise allowed them to push forward a significant distance. Tank destroyers proved effective, taking out columns of light American armor. However, once the Allied counteroffensive began, the advantages of the long-range gun could no longer fully make up for the flaws in the chassis and armor. Historical reports describe an episode involving a Jagdpanzer IV near a Belgian village in late December. The vehicle took up a camouflage position in the ruins on the outskirts. When a column of Sherman tanks appeared, the lead vehicle was taken out by a direct hit from over half a mile away, and the next shot destroyed the tank, bringing up the rear. This effectively executed the tactic of blocking the column between the disabled vehicles. The remaining Shermans tried to turn back, but the gun's fire knocked them out, one by one. 5 American tanks destroyed, the result of a well-organized ambush. However, When they tried to reposition, things went wrong. The ground was soaked from the rain, causing the self-propelled gun to bog down and lose mobility. The crew was forced to abandon the vehicle and retreat on foot, and an hour later, US artillery pounded that exact grid. On the Eastern Front, the situation was also escalating. In January 1945, the Vistula Order offensive began. Soviet troops broke through the defensive lines and pushed toward the German borders. German armored units launched counterattacks, but were defeated by the enemy's overwhelming numbers. Tank destroyers were used in rearguard actions, covering the retreat and holding off Soviet armor. Their powerful weaponry allowed them to engage from a distance, but the withdrawal along torn-up winter roads created brutal conditions for the drivers. One crew commander recalled an engagement in Silesia that took place that February. The self-propelled gun took up a position on high ground, providing cover for a retreating infantry regiment. When T-34 silhouettes appeared on the horizon, fire was opened from a range of nearly a mile. 3 tanks were hit. The others used the terrain to take cover. A firefight ensued. Tank units tried to flank the position, while the gun crew returned fire, shifting their sectors of fire. The battle lasted about an hour, until a shell struck the left side of the superstructure. The armor was damaged, and the loader was wounded by shrapnel. The commander decided to withdraw, as the infantry had already cleared the pursuit zone by that time. However, on the descent, the gun barrel dug into the ground, spinning the vehicle around. The crew had to spend time maneuvering, while enemy artillery zeroed in on the position. March and April marked the final stage of the war in Europe. Soviet troops were storming Berlin, while Allied forces advanced on the Western Front. The remaining self-propelled guns were used in urban combat, on roads, and in forests. Some vehicles were destroyed in clashes, while others were abandoned by their crews after running out of ammunition or fuel. The vehicles, unofficially dubbed Guderian's ducks, often broke down during marches, were used as barricades in urban combat, or were abandoned by retreating crews due to failures of the overloaded suspension. The operational history of this vehicle ended with the surrender of Germany on May 8, 1945. The Jagdpanzer IV did not become the decisive factor the military leadership had counted on. An effective gun was paired with structural flaws in the hull, poor quality armor, excessive weight on the front end, and poor off-road capability. Total production amounted to 769 units instead of the planned thousands per month, highlighting the disconnect between engineering designs and the actual production capabilities of the time.